I'm Robyn Griggs Lawrence, Editor-in-Chief of Natural Home Magazine, and in past web videos we've been following the progress of a greenhouse that's being built here in Boulder, Colorado. It's going to be a zero-energy home. It's going for some great green certification, and as you can see, things are starting to happen here. The walls are up, and while it may look like a very traditional house, it's definitely not. And Ron Flax, the project manager, is going to explain to us what makes this house so green.
When you first look at this house, it appears very much like a traditional framed house. One of the things that's unusual about this site is that it's in a very high wind zone. The wind is rated here at 130 miles per hour, which put some real challenges on the design of the house to avoid having stud packs in the wall that prevented insulation. So we went with an engineered stud. The engineered studs have a great many advantages. They're considerably stronger than standard framing. They have much less waste than standard framing, both in the production of it, because they actually use waste products that are from other wood processes. It's much like OSB in that wood scraps and chips from other processes are glued together, in this case using a polyurethane glue, avoiding the formaldehyde, and then what you end up with is a stud that's entirely usable, which allows for much less waste in the culling process on the job site. The framers don't have to look for good framing material at any point. All of it is good, which allowed us also to order for the job site framing that was the correct length. So all the studs were pre-cut in the factory. So on the job site we had very little wood waste from the studs. It also allows for much greater insulation in the building envelope. We have places where traditional frame houses are above the headers and in some of the walls, corner details, the insulation is very difficult to achieve, allowing for less insulation and greater thermal bridging through the stud directly. And we've eliminated both those problems with the engineered studs. One of the things in this house that is kind of important from a design feature is the entire first floor is going to be a stained concrete floor. We went with 30% fly ash mixture, which is really pushing the envelope. In terms of what's feasible in the field today doing concrete. Now, fly ash is a waste product from coal burning, and its disposal is actually a pretty big problem. But it turns out that if by mixing into concrete, it makes the concrete a little harder to work with, but it makes the performance characteristics of the concrete quite a bit better. Plus, it allows you to use less cement in the mix, and the mining of cement is something that has some environmental consequences that are a little bit undesirable. So by adding 30% fly ash, we end up with a stronger concrete that is disposing of a harmful waste product and using less cement at the same time.
To follow the construction of this house, check out Robyn's blog From the Front Porch at naturalhomemagazine.com.